Hello friends, welcome to this very interesting session, application of engineering, mathematics of a higher order for a very useful health applications, which is to take care of the lower extremities rehabilitation. To share their research, applications, prototypes on this, which are called Stewart Platforms. We have Professor Josep Rossell, along with his colleagues who are engineers, Mr. Barkans, Mr. Vincent Vines of the Polytechnic University of Catalonia, which I would request him to correct my pronunciation, which is near Barcelona, Spain. Professor Joseph is here in Delhi to participate in an international conference, which is both on-site and online, and he has very kindly agreed to share the utility of this platform for rehabilitation purposes, as well as perhaps for business applications. So, sir, let's start with what is the purpose of, or what are the Stewart platforms?
Stewart platforms can be used for a multitude of technological, industrial, and medical applications because they allow highly precise reproduction of control movements with 6 degrees of freedom. This study proposed the use of a Stewart platform for the rehabilitation of knees, ankles, and lower extremities in general, simulating physical exercises that help their recovery and straightening.
Tell us more about the Stewart platform, maybe with a diagram or something.
Okay. Stewart platform is a parallel robot composed by 6 actuators attached to the fixed base and a mobile disc that operate independently. These actuators move a disc in 6 degrees of freedom, 3 translation about the axis X, Y, and Z, and 3 rotational movements about the axis, it's called pitch, roll, and yaw. That is, the 6 movements that a plane has when it flies. In fact, the first platform was constructed and designed by an engineer, Stewart, in 1965 for training the Lufthansa pilots.
Are these platforms built by your research team, or are they purchased, or whatever it is?
Yes, of course. We have designed, built, and put in functioning these 2 platforms. The biggest platform is constructed perhaps 8 years ago, and the smallest platform in 2 years ago. After we explain because we have 2 platforms and why we have a small platform and another biggest platform is a necessity in the simulating.
Commonsensically, in how many directions, therefore, this is configured?
Yes. We can observe this vectorial scheme of a Stewart platform.
Okay.
The best important thing is to put in a correct place the attach points in the top, the points P1, P2, P6, and in the base, P1, okay, P2, P6, because the symmetry of this mechanism is the most important thing in order to move in a very high precision.
Why do we call this inverse kinematics methodology?
Okay. The inverse kinematic is a technique that allows determining the movement of any parallel robot to ensure that a final actuator is located in a specific position. The calculation of inverse kinematic is a complex problem. The calculation of inverse kinematic needs solving to a series of equations whose solution is not unique. The objective of inverse kinematic is to find the values that the joint coordinates of the robot should take so that the top plate is positioned and oriented according to a desired position and orientation. This is the methodology of inverse kinematics.
And so how are these calculations done for the legs or anything else?
Okay.
Though we may not be able to go into details of it, but the basic principles of it.
Okay. We need to calculate the norm of this vector. This vector is the vector that attach 2 points, P I and BI in the base and in the top. And obviously, the vector P is the vector that connect both origins. The vector P move with the time. And we have another very important thing that is this R matrix composed by this other three matrix is the Euler matrix. With this kind of norm, we can calculate the length of each actuator at any time. In fact, we can move the actuators with micron precision. Micron precision in that moment, every 5 milliseconds. But we can move more speed if you want, each 1 millisecond. Because the Stewart platforms, the most important thing is not the movement, it's easy the movement, but not the control in real time. The real time is the most difficult thing when we work with Stewart platforms.
Now, do you have some video examples of this?
Oh, of course. We have 3 short videos in order to appreciate the precision and the accuracy of an Stewart platform.
Yeah. Let's do something.
We can see the 3 linear movements around the long axis X, Y, and Z. The translation.
Oh, that's called translation. So how many side movements are these?
The rotational movements, roll, pitch, and yaw. The rotational movements in the space. And it moves with 6 degrees of freedom. 3 translation, 3 rotations. Combined movements.
So this is a prototype.
Yeah.
Has any company started manufacturing them?
Not a lot. We have to put in a specific. It's difficult, yes, because each actuator, the cost is 3,000 euros.
Oh,
3,000 euros. The other thing we have construct with our research group, but the actuators not. American actuators.
Okay.
The second.
This is for the path tracking.
Path tracking. We have 8 videos in YouTube if you are interested in watch another simulations movements.
Why this laser kind of light is there?
Yeah. Follows perfectly circumference.
Oh, that's just to check also.
It's a simple movement, but the precision is very high. And it stop, vertical line.
Okay. Again, perfect.
Yeah. And then a small circumference with high precision too. And then the platform stop and put the
dot on
the laser point in the center of the target.
Oh, straight away it goes in then the center.
Yeah,
the pin
in the center, and they move, but the point doesn't move. This is only for appreciate the accuracy of these platforms. And the last video,
what are these synchronized movements?
The synchronized movements of both platforms. We can observe that the 6 actuators of this platform and the other 6 actuators work independently, watch on the others, but the movement is practically perfect. We have put this device.
Yeah, we see the camera also there.
In order to observe the movements, the precision movements.
And we also see the camera taking pictures there.
The camera in order to watch the
So-
position of.
So the camera won't fall.
Yeah. Okay. Combine movements. There are short videos, 1 minute, 1 minute, 1/2, not more.
And you said there are more on the YouTube?
Yeah, we have eight, I think, 8 videos, different things,
Okay.
but all are interesting to watch,
I
in
see.
my opinion. Okay.
Now, so we want to take a stock of what are the main things done in the study.
Okay.
Hmm.
In this initial study, the following points have been addressed. Obtaining the dynamic model of the platform, but in this case, our research team has a lot of information about this point, have a very experience with Stewart Platforms. Then, obtaining the dynamic models of the human leg, including ankles and knees. This is the second initial study. Analysis and parameterization of the correct exercise for ankle and knees. The development of implementation of control algorithm for monitoring rehabilitation trajectories.
Now, in this case, control algorithms will mean the mathematical equations and all that.
Yeah,
Hmm?
yeah, of course. The generation and simulation of trajectories for the ankle and knees rehabilitation task.
This has been tried or it is in use for the ankle and
Yeah.
knee rehabilitation.
Yeah.
Just prototypes are there or they are actually in use also?
Well, with this prototype, we can make some changes in order to obtain the best trajectories for ankles and knees, but we need the help of therapists and traumatologists, obviously.
So this is basically
It's
the
another-
machinery help. Yeah.
Okay. And finally, the experimental validation of the obtained results.
Okay. So you now want to show the simple rehabilitation mechanism.
Yes, we have some simple rehabilitation mechanisms for ankles or knees, but in this case are not Stewart platforms, are
Okay.
simple rehabilitation mechanisms. And other simple rehabilitation devices for ankles we can see in this image, but it's not our
Stewart.
intention. It's not an Stewart platform, obviously. Okay, we can
What can
talk
we achieve?
about the objective of this presentation.
Yeah.
The first objective is the range of motion exercises. Stewart platforms can be programmed to move the knee and ankle joints through a variety of movement exercises. By controlling the movement of the platforms, traumatologists and physical therapists can fine-tune the flexion, extension, inversion, eversion, and rotation on both joints. This helps restore and improve joint mobility and flexibility. The second objective is strengthening exercises. The platforms can apply resistance and load the knee and ankle joint during rehabilitation exercises. By adjusting the forces exerted by the platform, therapists can customize the resistance to match the individual's strength and gradually increase it as the muscles get stronger.
And this is also tried at the prototype level?
Yeah.
Huh?
Yeah.
Okay.
This helps improve muscles strength and stability in both the knees and ankles.
Yeah.
The third objective is the balance training. An advantage of the Stewart platforms is that they can simulate unstable surfaces to challenge the balance skills of the knee and ankle joints. By introducing controlled perturbations and tilt movements, the platform can mimic real-life situations that require joint stabilization. This helps to improve balance control and joint stability. Gait rehabilitation, these mechanisms can be integrated into gait training systems for patients recovering from knee and ankle injuries. By replicating the natural walking pattern, therapists can adjust the platform's movements.
So again, it is tried at the prototype level? Okay.
To facilitate proper gait mechanisms, this aids in reestablishing a normal walking pattern, promoting a smooth and coordinating gait, and improving the strength and mobility of the knee and ankle joints.
Right.
And finally, the integration. The platforms can combine it with sensor technology, such as force plates or motion capture systems, to provide quantitative data on knee and ankle joint performance during rehabilitation exercises.
Yeah.
This allows therapists to monitor progress, track improvements, and make adjustments to the rehabilitation program based on data. Finally, virtual reality feedback. By incorporating virtual reality technology, Stewart Platforms can create immersive and interactive environments for knee and ankle rehabilitation. Visual and auditory feedback can be synchronized with the platform's movements, providing real-time feedback and motivating the patient during their rehabilitation sessions. Well,
So these are using the Stewart platforms.
yes.
Okay.
In these two images on the left, we can see a small Stewart platform for rehabilitation of
Foot.
yes. And on the right, we can observe the patient with the feet in two Stewart platforms. And at the end, in the image, we can observe the virtual feedback reality. That is the points 5 and point 6 of the objectives. Then, well, the conclusions.
But
no?
before that, I was interested in discussing with you applications other than what you've mentioned.
Yes. This is in this presentation is a medical application,
Okay.
but obviously it's not the unique application. For instance, suppose a ship who is in the sea, and they have to put the containers in a port, and the sea is very moving. It's not possible because they wait that the sea is more calm in order to put the containers.
Yeah, but then if they have to wait, they'll be paying and everything, congestion and whatnot.
That is. Then, if inside of this ship you put a Stewart platform, and hydraulic Stewart platform in this case, because they
Weight.
need to very, very high load weight. And in this platform, we put a crane, but the platform compensates the movement of the sea, the waves. When the sea is in this direction, platform in this other direction. When they,
That means this will be for the whole of the deck.
yeah,
Huh?
yeah.
Okay.
And then you can put the containers in the port, and when finished, the ship come back.
So you save the money of waiting charge and all
Yes.
that. Huh?
This is one application, and real application. But there are another. For instance, we can observe the platforms, the wind turbines in the sea, offshore wind turbines, that they are put inside of a very big platform.
Yeah.
This platform moves with the waves again. And then we need to make some
Stabilization.
control forces in order to stabilize. Because if the tower of these wind turbines move more than 5 degrees, they lose a lot of energy.
Yeah.
Then we have to, in a theoretical way, to find control forces in order to stabilize the base of this platform. But in our laboratory, we need two platforms. Why? Because the first platform in the base is the movement of the waves.
Yeah.
And the second platform compensates the movement of the waves in order, in this point, not move. This move, this other compensate.
Yeah.
But in laboratory, we need both platforms, not only one, because the ship is the first platform, and the second is with compensate.
Yeah.
But it's very difficult because it's in real time.
Okay.
In real time, control the platforms is not easy. It's the most difficult task is the real control in time.
But people have been trying to make something about it.
Yes. Yes.
Because it makes a lot of sense.
Okay. Then the conclusions of this presentation is the Stewart platform are very precise mechanism that can be used for a wide industrial and medical applications. Our research group has accumulated extensive experience in the design, construction, programming, and control of Stewart platforms over the years. We have presented a medical and practical application of this type of mechanisms, which can be useful in the field of ankle and knee rehabilitation. We have established contact with medical specialists in this subject, and they have expressed their interest in collaborating with us to carry out the proposal. And with the help of therapists and traumatologists, it is possible to monitor progress, track improvements, and make adjustments to the rehabilitation program based on data. But this is a future task. And finally, visual and auditory feedback can be synchronized with the platform's movements, providing real-time feedback and motivating the patient during their rehabilitation sessions. But this is a future task too. Okay, that's all.
Wonderful, Professor Rossell. Would you like to add anything? Or I think we have covered this a lot, and we congratulate yourself and your team of engineers. Very good combination of a mathematician and engineers. Generally they fight, but their cooperation is required for such a good application. And of course, the application, as you rightly said, where waves are there. And these are all future platforms which have to be there, and therefore, and this task has to be done. So somebody has to do it. And
thank you.
Are there a lot of people working on this research?
Yes.
Huh?
Yes.
Oh,
Yes. Okay, thank you very much for your opportunity, for giving me an opportunity to present my Stewart Platforms.
Students at this institute and other institutions would love this, and you've done it with so much care and so on.
Okay.
So we thank you, and this is Rossell for coming over and sharing this with us. Thank you.
Thank you very much. Thank you.